This is an example of writing a piecewise function for a tax example. So this table shows the state income tax for individuals filing a return in Kansas for their income tax. And the income is determined, or the amount of tax is determined by where the income falls. So between 0 and 15,000, the income or the tax is 0.035, so 3.5%, to change it to a decimal is 0.035 times the income. So as an equation, that would be 0.035 times x, where x is the income. And then if the income is between 15,000 and 30,000, then the amount of tax paid is $525 plus 6.25%. So as a decimal, that's 0.0625 multiplied by the amount of income in excess over 15,000. So to get the amount of income that's above 15,000, we would take the income and subtract 15,000 from it. So x minus 15,000 would give us the excess of the income that's above 15,000. And then last, if the income is above 30,000, then the amount of tax paid would be 14,625.5 plus 6.45%, so 0.0645 times the excess that's over 30,000. So this time we would use x minus 30,000. Okay. So for now, those are the three equations for the function t of x, the taxable income. Let's kind of start setting up t of x, the piecewise function. It's going to have three parts defined by this, and this area of income. So first, the function is 0.035x when x is between 0 and $15,000. And then second, the tax is defined by this red equation if it's between 15,000 and 30,000 for the taxable income. But this equation is not fully simplified, so before we write this equation in the second line of the tax function, let's simplify and combine like terms in this equation. So we would distribute 0.0625 into those parentheses. So that would be 0.0625x minus 937.5, and then add 525 to that. And then combine these two terms, we would get the 0.0625 x minus 412.5. So 0.0625x minus 412.5 is the second equation, and that's when the income is between 15,000 and 30,000. And then the last line is going to have to do with this last row where we wrote this blue equation. But again, this equation is not fully simplified. Okay, so again, we're going to distribute this number into this equation. That's 0.0645x minus 1935. And then we'd combine these two terms to get the equation 0.0645x minus 472.5. And that's when x is above 30,000. Okay, and we just get that by combining these two numbers to get that last equation.